Okay, so today we're going to be looking at extrema. Extrema are maxes and mins on a graph. Now, I'm sure you can probably point out maxes and mins on a graph if you have the graph of a function. And so we're going to look at the different types of extrema that we have, and we're going to look at how we can find those extrema. So the first thing I need you to know is the way that sometimes the AP talks about maxes and mins. So if you have an absolute or global maximum, okay, either one of those words work, then what you're saying is that f of c is greater than or equal to f of x for all x in the interval. Now, that means there is one y value, a specific y value that's greater than or equal to all other y values. That's going to be your maximum. Okay, if you're looking for a minimum, then the inequality is going to flip. You're going to have a specific y value that is less than or equal to every other y value in the interval. Okay, and then we've got relative or local extrema. We call them relative. That's a y value on the graph where the function changes from increasing to decreasing and vice versa. And then an absolute is the highest or lowest value on the graph of the function. That's what we've already talked about. So if we look at this picture right here, it says, okay, so the graph of y equals h of x is shown below. Determine the extrema on h of x on the interval a to f and then classify each. So let's look at global maximums. The global maximum is the highest of all max points on there. We can also call it the absolute maximum. So the highest point of the entire graph is here at E. The global minimum or absolute minimum is going to be the lowest of the low points on the graph, which looks like it's right here at D. Then local or relative are going to be low points, or I guess in this case we're maximum, so high points, but are not going to be the highest. So A is a high point, and C is a high point. So those are our relative. And then our local or relative minimums are going to be, let's see, B is a low point, and F is a low point, okay? So that's what, how we can identify absolute and relative, okay, or global and local. All right, extreme value theorem says if f is continuous on the closed interval and then f has both a maximum and a minimum value on the interval. So what it's saying is that as long as the function is continuous, then I can guarantee it's got a max and a min. Okay, it says for our example 2, for each function shown below, determine if the extreme value theorem can be applied on the given interval. So remember, the function has to be continuous for it to apply. So if we look at the function 2x minus 3 over x minus 2, this guy, since it's got a variable in the denominator, has a vertical asymptote. So we've got a vertical asymptote at x equals 2. Now, as long as that 2 is not in the domain, then we're okay. The problem is it's in the interval that we're given. So we have a vertical asymptote at x equals 2. Therefore, f of x is not continuous on the interval. So EVT doesn't apply. Okay. All right, the next one, we have e to the x minus 4 plus 3. Well, that guy's continuous on everything. It's a fully continuous function. So we're going to say yes, EVT applies because g of x is continuous on -5 to 5. All right, and the last one, x times x plus 3. Well, the x piece is fine, but this guy is not going to be, it's not going to even have a value, the domain, as if x is greater, no, if x is less than -3. So I can't go any lower than -3. So that's a problem because I'm going down to -6. So we're going to say domain is x less than or equal to, no, greater than or equal to -3. You can't go any lower than that. Therefore, EVT doesn't apply for, what were we, -6 to 6. Okay? All right, so next thing we need to know, and this is kind of a vocabulary day, is the definition of a critical number or a critical value. So a critical number or a critical value is a place where f prime is equal to 0 or f prime does not exist, okay? Then we call that a critical value on the function. So let's find our critical values for this. So in order to do that, we just need our derivative, so f prime of x. So if I bring my 3 down, that would be 2x squared minus, if I bring my 2 down, that would be 7x minus 4. And we want to know where that's equal to 0. So this guy we have to factor, so that would be 2x and x, and I think I need a 4 there and a 1 minus plus equals 0. Do whatever you need to do to factor it, okay? There's a million different factoring methods. All right, and then, because that'll give me -8 and plus 1. All right, so then that gives me my critical values are -1/2 and 4. Okay, so simple. We've done this before. All right, on this one, it requires the chain rule. So remember, when we're doing g prime of x, we repeat this guy right here. So we have 3e to the x squared plus 3x minus 5. The derivative of 4 goes, well, and then we need to multiply, hold on just a moment, by the derivative of the inside function, which is 2x plus 3. Then the derivative of 4 goes away. So we want to know where this is 0, or I should have said undefined, 0 or undefined. So when we do that, I'm going to, now e, remember, can never be 0. So I'm going to do 2x plus 3 is equal to 0, so x is equal to -3/2. So that would be our critical value. All right, a couple more. So now we've got functions are a little bit more complicated. So we're going to do the derivative of f. We're going to have to use the quotient rule. So f of x is equal to 2 d1, so that would be 2, minus 1 d2 over x minus 2 squared. So I'm going to simplify this. So this is going to, sorry, this is f prime. F prime of x is going to be 2x minus 4 minus 2x plus 3 over x minus 2 squared. So that would be -1 over x minus 2 squared. Now, if I want to set this equal to 0 or undefined, then I'm going to, I take the numerator, I can't make it 0, but I can make it undefined at x equals 2. So that's going to be my critical value. All right, on the next one, we've got to use the product rule. So h prime of x is going to be equal to x times 1 over 2 square root of x plus 3 plus square root of x plus 3. And we want to know where that's equal to 0 or undefined. All right, so that's going to be x over 2 square root x plus 3 plus, I'm going to get a common denominator, so I'm going to multiply this by 2 over square root 3, which would give me 2 times x plus 3 over 2 square root x plus 3. Yes, when we want to know whether that's 0 or undefined. So if we put it together, that would be a 3x plus 6 over 2 square roots of x plus 3. So we want to know where that's 0 or undefined. So let's see, it's going to be 0 when the numerator is equal to 0. So that would be x is equal to -2. It's going to be undefined when x plus 3 is equal to 0. So that would be -3. So those are going to be our two critical points. Okay, so then the next thing we're going to do is find the absolute extrema Okay, I don't know what happened there. I froze it. I tried to pause it, but okay. So now we're going to find the absolute extrema on a graph, and there's 3 steps. You need to find your critical points, you need to build a t-chart, and you need to answer the question in a sentence. So our step 1 is to find our critical points. So f prime of x is equal to 24x squared minus 6x minus 9. And so we want to know where that's equal to 0. Well, I'm going to take out a 3, so that would be 8x squared minus 2x minus 3 equals 0. So I think that's going to be 4 and 2. So 4 and 2, and then I got to put a 3 in there. So I need a 3 here and a 1 there. And then I need a minus 6 and a plus 4. There we go. All right, so that means my critical values are 3/4 and -1/2. So that's step 1. Step 2 is to build a t-chart. So in that t-chart, we're going to have our x value and our y value. We're going to take our endpoints, -1, then -1/2, then a positive 3/4, and then a positive 2. And I'm going to cheat and use my calculator, and we're going to plug these into the original y equation. So if I do -1, so let me do -1, store into x. Okay, so now I'm going to do 8x cubed minus 3x squared minus 9x plus 2. And that's going to give me 0. Then I'm going to do -0.5 and store it into x. And I'm going to come up and get that same function and give me 4.75. If you want to know what I'm doing, I am storing the critical value, so 0.75, I'm storing it into the x variable. And then I'm coming up here where I've already typed it in and doing that. So that's -3.065. And now I'm going to do 2 store into x. Then I'm going to come back up here, bring down that polynomial, and I get 36. All right. So step 3 is to write your answer. So we say we have an absolute max of, let's see, where's our max? 36 at x equals 2, and we have an absolute min of -3.065 at x equals 3/4. And that would be our final answer. All right, 2 more. We've got f of x equals x minus 2 sine x on the interval from 0 to pi. So first step is find our critical values. So f prime of x is going to be 1 minus 2 cosine of x. And we want to know where that's 0. It's not undefined, so we don't have to worry about that. So that would be that cosine of x is equal to 1/2. So that's where x is equal to pi over 3 in the first quadrant, and then in the fifth quadrant it would be 5 pi over 3. Okay, step 2 is to build my t-chart. So I'm going to have x and y. So my first endpoint is 0. Then I'm going to have pi over 3. Then I'm going to have 5 pi over 3. And then I'm going to have 2 pi. And remember, we plug back into our original function. So when I plug in 0, I get 0 minus 0. So that's going to be 0. Okay, sine of pi over 3 is square root 3 over 2. So I have pi over 3 minus square root 3. And then 5 pi over 3 is going to be a negative square root 3 over 2. So that would be a positive. So that would be 5 pi over 3 plus square root 3. And then at 2 pi, sine's going to be 0, so we'll have just 2 pi. Okay, so pi over 3 is about, well, 3 divided by 3, so it's about 1 minus 1.7, which is a negative 0.7. 5 pi over 3, let's see, 5 times 3 is 15, so that's about 5 plus 1.7, so that's about 6.7. And 2 pi is about 6. So my absolute max of 5 pi over 3 plus square root of 3 at 5 pi over 3, an absolute min of pi over 3 minus square root of 3 at pi over 3. There we go. There's our answer. All right, last one. We've got cube root of x minus 2 squared. So I'm going to rewrite this, and I'm going to write it as f of x equals x minus 2 to the 2/3. All right, so the derivative, f prime of x, is going to be 2/3 times x minus 2 to the negative 1/3. So when I rewrite that, that's going to be 2 over 3 times x minus 2 to the 1/3. And we want to know where this is 0 or undefined. Well, it can't be 0 because the numerator can't be 0, but it can be undefined. So it's undefined at x equals 2. Okay, so now we've got to see if 2 is part of the original domain of the function, which it is. We can take the cube root of 0, so we're good. So step 2 is to build my x and y. So I'm going to have my endpoint 1, my critical value 2, and my other endpoint 10. So if I plug in 1 minus 2 is negative 1, squared is 1, cube root of 1 is 1. If I plug in 2 minus 2 is 0, squared is 0, cube root is 0. If I plug in 10 minus 2 is 8. The cube root of 8 is 2, 2 squared is 4. Okay, so now there are my values, so that was a pretty easy one. So my answer, I'm going to have the absolute max of 4 at x equals 10, and I have an absolute min of 0 at x equals 2. All right, so if you have any questions on that, come see us. But we'll move on to curve sketching and increasing and decreasing and things like that next class period. Bye, guys.